Hello everyone, myself Prajwal Anand Mungana. Today we're discussing about my project builder, uh, which is prepared by myself Prajwal Anand Mungana and my friend's name Shishidhar Wire. My project discussion is desktop communication lab, which is consist of 10 topics, which I mentioned here. First one is AM versus FM modulation demonstration using software. Next, sampling reconstruction, fiber optic communication module, satellite communication system calculator, network switching module, circuit packet message, GPS working demonstration, radio receiver sensitivity and selectivity analysis, mobile communication evolution 1G to 5G, noise communication filtering, microwave communication link. First we see about our first topic, AM versus FM modulation using software demonstration. Amplitude modulation, which is of AM, carrier amplitude varies with message signal. Frequency modulation, FM, carriers frequency varies with message signal. EM is simple but noise poor. FM offers better noise immunity. Software demo show carrier wave modulating signal, EM waveform, FM. FM performs better in noise environments. And next we see about our next topic, sampling reconstruction. A continuous signal into a discrete form, and reconstruction recovers the original signal using a low pass filter. Sampling converts continuous signal to discrete signal. Sampling frequency greater than or equal to 2 into sampling frequency. It is undersampling causes analyzing distortion and reconstruction using low pass filter. Software demo show original signal, sample signal, reconstructed signal, low pass filter, analyzing the example under sampling used in digital communication. And next we see about our next topic, which is fiber optic communication module. In fiber optic communication module, light signal is transmitted through optical fiber to achieve high speed and low loss data transmission. Main components: attenuation calculator, bandwidth calculator, dispersion, pulse, broadening. First we discuss attenuation calculator. It is a loss of optical power. It is a loss of optical. It is a loss of optical power as light travels through the fiber. It is a higher distance in more power loss and measured in decibel dB. Low attenuation in longer transmission distance. Next, bandwidth calculator. It is the maximum data rate that a fiber can support without distortion, where bandwidth decreases as fiber length increases. It means bandwidth decreases as a fiber length increases. Signal mode fiber has very high bandwidth, and higher bandwidth has higher data rate. Description. Pulse broadening. The description, the dispersion causes the dispersion causes spreading of light pulse and leading to overlapping of bits. The different wavelength travels at different speed. It causes intro symbol interference, limits the maximum data rate. It is low dispersion to clear signal reception. And next we see about our next topic, which is satellite communication system calculator. Linked budget. The linked budget is an analysis of all gain and loss from transmitter to receiver to determine the carrier to noise ratio. It includes the transmit power, antenna gain, free space path loss, system noise. SN ratio includes uh, quality and reliability of the satellite link. Look angle, azimuth and evolution. Look angle define the direction of the satellite antenna from the Earth station. Azimuth angle, horizontal discretion of the satellite measured clockwise from north. Evolution angle, vertical angle between the horizon and the station and the satellite. Proper alignment ensure maximum received power and minimal interference. Orbital velocity, circular orbit. Orbital velocity is the speed required by a satellite to remain in stable circular orbit around the Earth. High altitude, lower orbit velocity ensure balance between uh, gravitational pull and centrifugal force. And next we see about our next topic, which is network switching model. Circuit switching, packet switching, message switching. These are the three types. Which is first we discuss about circuit switching. It established a dedicated communication path between sender and receiver for the entire duration of transmission. Example, telephone network. Uh, it data splits into packets. Example, internet packet switching. It divides data into packets that are transmitted uh, in, independently and reassembled at the destination. Message is divided into small packet. Uh, each packet may follow different paths. Packets are uh, reassembled at the destination. Example, internet. Advantages: efficient, flexible, reliable. Message switching. Message switching transmits the complete message using a store and forward method without compressing. Circuit packet circuit low delay, inefficient. Packet efficient, flexible. Packet switching dominate modern network. And next we see about our next topic, which is GPS calculator demonstration. In this GPS demonstration, in this GPS calculator demonstration, GPS calculates the distance between a satellite and receiver by messaging, the time delay between signal transmission and uh, reception, time delay measurement. Each GPS satellite sends a time stamped signal. The receiver notes the arrival time. Time delay delta t equal to reception time minus transmission time. Time delay is usually measured in microseconds, and you can see this microseconds formula. I mean some micro distance calculation. Distance is calculated using distance equal to speed of light into time delay, where speed of light c equal to 3 into 10 raised to 8 meter per second, and time delay delta t in second. For microsecond, distance m equal to 3 into 10 raised to 8 into delta t into 10 raised to minus 6. And we next you see about our next topic, which is radio receiver sensitivity and selectivity analysis. First we see about sensitivity, and next we see about selectivity. In sensitivity is the ability of a radio receiver to detect very weak signal, indicates the minimum signal power required for acceptable reception. High sensitivity allows long distance communication, depends on noise figure bandwidth, signal to noise ratio, this is SNR. And then we see about the selectivity. Selectivity is the ability of a receiver to accept the uh, desired signal while rejecting adjacent channel signal, prevent interference from nearby frequency, achieved using Norway bandwidth filter. High selectivity improves signal clarity. Performance analyze parameters. Next we see about performance analyze parameters, which is noise frequency, bandwidth, and SNR. Noise frequency measures of a noise added by the receiver. Bandwidth frequency range the receiver can process. SNR ratio of the signal power to noise power. And next we see about our next topic, mobile communication evolution 1G to 5G. From analog voice service in 1G to ultra low latency high speed data service in 5G. In 1G first generation supports analog voice communication only, low noise quality and poor security. Example systems EMPS. And next we see about second generation, which is 2G, introducing digital communication, supports voice and SMS. Improved quality and security. Example technology, GSM, CDMA. And next third generation, which is 3G, enable data service and video calling. High data rate. Then 2G supports mobile internet and multimedia. 4G, fourth generation, provides high speed internet access, fully packed switching network. Technology used LTE, supports HD video streaming and online service. Fifth generation, which is 5G, offers ultra low latency and very high data rate, supports IoT, AI, autonomous system, enable smart cities, autom- automation, and industry 4.0. And next we see about our next topic, which is noise communication filtering. Noise communication filtering, we see about noise is unwanted random signal that interferes with the discrete signal and uh, degrades signal quality. First we see about low pass filter, high pass filter, and band pass filter. First we discuss about low pass filter. Allows low frequency signal to pass attenuation frequency above the cutoff frequency. Remove high frequency noise, used in signal reconstruction and noise reduction. And next we see about high pass filter. Allow high frequency signal to pass attenuation frequency below the cutoff frequency. Removes low frequency noise and DC components, used in communication receiver and audio system. And next we see about band pass filter. Allows a specific region of frequency to pass. Blocks frequency below lower cutoff F1 and above upper cutoff F2. Selects the discrete channels, used in radio and wireless services. And we see about our last topic, which is a microwave communication link. Line of sight microwave link. Microwave communication required an unobstructed line of sight. Signals travel in straight line and do not bend around obstacle. Any abstraction causes signal fading or link failure. Used in cellular, vacuole, and point-to-point link. And next we say about link budget calculator. It calculates received power and link margin, used to evaluate the performance of a microwave link. Calculate received signal strength by counting for transmit power, antenna gain, free space path loss, system losses. Rain attenuation calculator. Rain weakness, microwave signals escapely at high frequency. RAN causes abstraction and scattering of microwave signal. Effect increase at a higher frequency, about 10 GHz. Calculate estimate calculate Calculator estimates uh, signal loss due to rainfall intensity, important for link reliability design. And next we see and this what we see about our 10 topics. Thanks. Hello everyone, myself Prajalan Mugana. Today discussing about our mini project which is a desktop communication project. Our department is ICT, which is Introduction to Communication Engineering, and my project is which is a desktop communication project which contains 10 topics. You see, and first we discuss about first topic which is AM versus FM comparison. First we see about AM versus FM comparison, which is there are carrier wave, modulating signal, FM waveforms, FM waveforms, and this is EM waveforms. First we see how its carrier wave works. By increasing its voltage, you can see how waves are varying. By decreasing how the waves are varying, this is how carrier wave works. And next we see about modulating wave by decreasing by keeping 20 volt. See the wave how it's working. And then we keep next we keep off to 70 volt. Then you can see how the waves are working. And next we see about our EM waveform, which is how it works. See, by decreasing all the by how see it's become parallel, and by keeping this here, you can see that how it's work. And we next we see about our FM waveform. In 4 hertz, 4 hertz, 5 hertz, in 14 hertz, you can see that how it's work. See how it's working. By increasing its more, see how it works. This is how it works. And next we see about AM and FM differentiation. AM means amplitude modeling, frequency modeling. It's FM. Amplitude of curves voltage, instant frequency hertz, and this is a formula. And this in amplitude modulation is low, frequency modulation is high. Carrier plus sidebands approximately constant in frequency models. And next we see about which is next topic, which is sampling reconstruction. In sampling reconstruction, there are original analog signal, sample signal, reconstructed signal, analyzing example. These are the signals which are next. First we discuss about original analog signal. By increasing 2 to 6 7 hertz, you can see the waves how it changes. Next we see about sample signals. See, here's a 4 into FM. It's if we decrease up to its 1, you can see the point. It's detecting only 1, but we decrease up to 5. It's showing how it works. And next we see about our reconstructed signal, which is a low pass filter. This is low pass filter. Analyzing example is undersampled. You can see here red line and dotted blue line how it works. And next we see about the next topic, which is fiber optic communication. This is a fiber optic communication starts transmission. This is started. By stopping, it will stop. This is a transmission. This is fiber optic calculator. You can calculate the input power, fiber length by putting input powers and fiber length, loss BP or kilometer. First we see putting the values. You can put and calculate. Output power is 6 dB. This is what it shows decibel. And by putting next, we can see putting the values 8. If you don't calculate, it's not showing. Okay, so, next we see about our dispersion pulse modeling by putting 4 and 10. We can calculate it. See, this is how it calculates pulse modeling in the 36 point ns 36 ns. And next we see about, which is our next topic, satellite calculator. You can see a satellite calculator. Our first topic is linked budget, look angles, and optical velocity, which is a circular orbit. First, by putting the input in a link budget, you can see some inputs in here. You can put here by calculating. You can see that it's giving minus 232.6 dBs sample. This is how its calco works. In look angle, you can also put some values here. By putting some values, you can see the values here. And in optical velocity, we also put some values here. If you put values, it will show some optical velocity is 7.91 km per second. This is how our satellite communication calculator works. And next we see about our next topic is network performance parameters. See, network switching modulation. These are three types of circuit switching. This is circuit switching and packet switching and message switching. First we see about our circuit switching. See in here, dedicated path is established before communication. By simulating this is dedicated path established data sent path released. And next we see about our packet switching, which is data divided into packets and sent independently. Simulate it. You can see here. Packet 1 sent, packet 2 sent, packet 3 sent. But it's independently, but you can send, divided it, different routes. And next we see about our message switching, which is entire message is sent using store and forward. By simulating this, you can see message stored at nodes, forwarded, delivered. This is what it happens. And next we see our next topic, which is GPS working. This is GPS distance calculator. See, by putting some values, it's calculated the distance minus 1200 meters timely. It's calculated the GPS distance. How this GPS works. And next we see about our next, which is our next topic, is radio receiver sensitivity and selectivity. You can see our next topic, which is sensitivity, and next we see selectivity. This is also calculator, sensitivity calculator. By putting some values, we can calculate the it. See, receiver sensitivity minus 109.99 decibel meter. This is what given the value. This is how sensitivity calculator works. Selectivity calculator. This is also same. We have to change put some values, increasing or decreasing. Selectivity is equal to 4. This is how our radio receiver sensitivity and selectivity works. And our next topic is mobile communication evaluation. See, this is 1G, 2G. How you can see the wave formations, how the waves are working now. In 3G, you can see the waves. It's became in 4G. You can see the waves, how it's changing there. In 5G, you can see the more waves are closer to one to closer. You can see here in first, it's moving very fast. In 2G they are little bit closer. 3G you can see. In 4G you can see there's a closer only. In 5G it's too closing. I think in 6G also it becomes so close. And which is our next topic. You can see our next topic, which is noise filtering techniques. See, this is how our noise filtering technique is: low pass filter and high pass filter. How you can see the waves red and blue. See, in low pass filter, see it's going through it only. You can see the blue line and red line. But you can see in high pass filter, it's changing its waves, and you can see in band pass filter also, it's became too short. This is how noise filter technique and how low pass and high pass filter and band pass filter works. You can see through the waves. This is a high pass filter and this is low pass filter. And next we see our next topic, which is digital modulation scheme. In a digital modulation scheme, you can see microwave linked budget calculator, RAN attitude calculator, microwave versus optical fiber parameters, microwave link, optical fiber. You can see last one. First we see line of sight microwave link. Start streaming. You can see here. By stopping, it will stop. If it starts again, then it starts. If you continue, the process will continue. If it stop, it stop. This is line slide microwave link. Next we see about microwave linked budget calculator. This is a calculator. You can calculate the values by putting some values with 32, 20. You can put 22 here, and 18. You can put here also some values. By calculating, it's received power minus 25 dB, decibel meter. dB means decibel. This is how microlink budget calculator works. Next we see about our rain altitude calculator. This now works. First we rain rate, path length, and specific altitude. You can put the values here. Changes you can change here only. By calculating, it will give total rain altitude minus 542.8 dB decibel. And next we see about our microwave versus optical fiber. Microwave versus microwave link versus optical fiber. What are the parameters? So what are the parameters used to compare this? Transmission media. In microwave, air, wireless, glass fiber used in optical fiber. Bandwidth high in microwave, very low in very high in optical fiber. Line of sight required in microwave link, not required in optical fiber. Installation easy and fast in microwave link, and difficult and costly optical fiber. And next we see about noise immunity, medium in microwave link, very high in optical fiber. Weather effect, affected by rain in microwave link, not affected in optical fiber. This is how we completed our 10 topics. This is how we completed our 10 topics. Since this is the last topic, this is our mini project, which is a desktop communication project. Thanks.